Hey everyone, this is Mr. Gucci here with your distance learning lesson for the week. All right, this is chapter 10, Stoichiometry. So we're starting learning some new stuff again. I hope you follow along. I hope you do the worksheet that is attached to this video. And I hope you reach out to me with any questions that you may have. Maybe jump in and join me for some of those weekly meetups that I'm hosting. All right, so let's get going. Chapter 10, Stoichiometry. So the first question, of course, is what does stoichiometry mean? Well, stoichiometry means calculating quantities, amounts of stuff in chemical reactions. So if we want X amount of product, how much reactant are we going to need to use? Or if we have Y amount of reactant available, how much product can we make from that? Here's a real world example. So this is a process to use silver nitrate and copper metal to produce pure refined silver. So a question might be, if I use 5 moles of copper, how many moles of silver will I produce from this reaction? Or if I wish to produce 27.3 moles of silver, maybe a client of mine has ordered it, how many moles of silver nitrate am I going to need to begin with? Right, now this is just an abstract example. This is a real world problem that a lot of chemists are dealing with right now. You might have heard that there is a shortage of the reactants that are needed to run the COVID-19 tests. So, a stoichiometric problem, practical real world problem that a lot of scientists are dealing with is if I need to run 10,000 tests, how many moles or grams or kilograms of reactant am I going to need? So these are real world chemical problems. Stoichiometry is the backbone of the day-to-day work that chemists do. Okay? But you are probably more familiar with another application of stoichiometry, and that is cooking. All right, cooking is in fact just chemistry that you get to eat when you're done. And you use stoichiometry when you cook, specifically when you cook a large amount of stuff, you might not have even realized it. So, for example, let me tell you how you might have used stoichiometry in the past. Okay, let's give you an example of a cupcake recipe that I found online. Don't actually use this recipe. I understand there's more that goes into a cupcake, but let's take a look at this basic recipe. To bake 12 cupcakes, you will need 1 cup of sugar, 2 large eggs, and 3 cups of flour. Okay? Now, again, cooking is just chemistry that you eat. The reactants are these ingredients. These are the reactants. And what is the product? The product is the 12 cupcakes. So if you've ever baked before, you have had reactants, the list of ingredients, and then you've had products, those things that you baked that you got to eat when you're done. But let's take this recipe and let's look at it as if it were a chemical equation. Let's take these reactants and these products, all right? I wrote cupcakes here, I meant products. Let's rewrite this recipe as if it were a chemical equation. And hey, here it is. I've already done it, okay? So 1 cup of sugar plus 2 eggs plus 3 cups of flour gets you 12 cupcakes. All right, great, perfect. Perfectly useful recipe if you want to make 12 cupcakes. But what if you don't want to make 12 cupcakes? What if, say, you want to make 30 cupcakes? I don't know why. Hopefully you're not hosting a party. Maybe you're just bored and you want to make a bunch of cupcakes to eat. Okay? Well, here's an actual question that you might deal with when you're cooking. This recipe is for 12 cupcakes. But if I want to bake 30 cupcakes, well, now how many of the ingredients am I going to need? Now, maybe some of you are good enough on your ratios that you can figure this out with any complicated math. You're looking and you're seeing, oh, okay, this recipe calls for 12 cupcakes. If I want to bake 30 cupcakes, I can see, oh, that is 2.5 times larger. So basically, I'm just taking this recipe, I'm making it 2.5 times bigger. So instead of 1 cup of sugar, I would need 2.5 cups of sugar. Instead of 2 eggs, well, what's 2.5 times 2? You would end up needing 5 eggs. So if you're good with ratios, and these are just all easy whole numbers, maybe you say, hey, I can look at this, I can see I need 5 eggs. This recipe is 2.5 times bigger. 2 times 2.5 is 5. I need 5 eggs. But you're not always going to have the luxury of nice whole round numbers. In fact, you rarely will in chemistry. And so because it is going to get a little harder, I challenge you to use the method that we've talked about before, that method being dimensional analysis. So let's try dimensional analysis to solve this, okay? Now, dimensional analysis, remember we start by identifying what our given is, what our starting amount. And in this case, the starting amount is 30 cupcakes. That is our given. And what is the unknown in this problem? What are we trying to convert cupcakes into? Not literally, we don't want to convert cupcakes into a thing. We want to figure out how many eggs. Eggs is the unknown here. So let's set up this problem like we've learned before. We're starting with 30 cupcakes over 1. And we are going to be converting it into eggs. Okay, hey, we want to get out of cupcakes and we want to convert it into eggs. So let's give it a shot. We want to get out of cupcakes, so cupcakes goes on the bottom so we can cancel out those units. We want to turn it into eggs, so we should put eggs on top. Out of cupcakes into eggs. Great, but what numbers go here? What is the relationship between eggs and cupcakes? Well, this is where we go look at that recipe. We look at the numbers of the ingredients in the recipe, and we see that according to this, you need 2 eggs for every 12 cupcakes. The conversion factor here is 2 eggs is what's getting you 12 cupcakes. So let's plug those numbers in. The relationship is 2 eggs for 12 cupcakes. The cupcake units cancel. That's why we set it up that way. Let's multiply across the top. 30 times 2 is 60. 1 times 12 is 12. 60 divided by 12 is 5. Use a calculator, guys. No reason to struggle in these hard times. The answer is 5 eggs. Now, that's the exact same answer that we got up here just by doing a little bit of ratio work, okay? But again, it's not always going to be that easy, right? It will not always be that easy. It will get harder. And so that's why we do these dimensional analysis problems where we identify the given, we identify the unknown, and we write down or keep track of somewhere what our conversion factor is that we got from the recipe. Let's try another one. All right, let's do another one I got set up here on the next slide. Remember, if you want to just pause and review what I've done here, do so anytime. All right, no reason you got to just listen to this all the way through. So let's say now instead of wanting 30 cupcakes, I only want 6 cupcakes. I only want 6 cupcakes. That right there is our given. That is what we know we're starting with. The question is, how much flour do you need? That is the unknown here. All right, so we've identified the given. We've identified the unknown. Let's set up our problem. 6 cupcakes. Now, I know a lot of you who are good with the ratios like, Mr. Gucci, is this the harder one? This one looks just as easy as the last one. Maybe you already got the answer in your head already. Well, again, shut up, all right? Shut up. It's going to get harder. So if you think you got this, then just jump onto the worksheet. What are you waiting around for, okay? Well, I'm not going to scold you. I can't see what you're doing right now, all right? So here we go. We want to get out of cupcakes into flour. So let's put cupcakes on the bottom and flour on top, okay? Now, what are the numbers that go along with these units? Once again, we go look at the balanced chemical equation up here. Our recipe, we see that flour, 3 cups of flour, is what we need for 12 cupcakes. So here we go. We got the numbers in. We cancel cupcakes. 3 times 6 on the top is 18 cups of flour. I should specify this is cups. And on the bottom, 1 times 12 is the doy, 12. Now, what is 18 divided by 12? I don't know. Get out your calculator. Beep, boop, beep, beep, boop. 1.5. 1.5 cups of flour. 1.5 cups of flour. That is how much flour you are going to need for this modified recipe. Now, again, maybe you smarty pants out there were thinking, oh, 12 cupcakes, 6 cupcakes, I'm just cutting everything in half. Good for you. But it will not always be that easy. Prepare that you will need to do a bit more complicated dimensional analysis down the road. Anyways, I think you guys have enough what you need to work on the first set of problems on this worksheet, okay? Get going on it. If you have any questions, please email me or join me for my Wednesday and Friday Zoom meetings where I can answer any questions that you have. Good luck, everyone. Have a good day.